Hi, everybody.
Hello.
Okay, we are ready for lesson 3-5. All right, what we're going to be doing is some solving. Back to algebra stuff. Most people like this one. Okay, the thing to remember is that exponents and logarithms are inverses of each other, which means they undo each other. So if I have something in exponential form, I'm probably going to need
a logarithm.
And if I have something in logarithmic form,
I'm going to need an exponent.
Okay.
Notice when you look at this, just to piggyback on that, if what was inside the logarithm is when you rewrite it, you get y by itself because you've solved for it. And if you're going the other way, if you've got an equation written in this form over here in exponential form and you're solving for x and you rewrite it, you get x by itself. It's kind of cool.
It's magic.
Weird.
Okay, the other thing to remember is that when you're switching back and forth, you can only do it when you have 3 pieces.
3.
A base, an exponent, and an input or a number.
Need 3.
Okay, properties.
And there's 3 of them.
There they are.
Hey, should we just stop the video? Goodbye.
Bye, see you later. No, you should have covered these, but let's go a little bit more in depth on our coverage. And let's show them where one of them comes from. Let's prove algebraically why this is true.
Should we go over them real quick?
Okay. So yeah, what is number 1?
One says if you are multiplying inside of a logarithm, you get to take the logarithm of both things separately and add. This comes directly from the rules of exponents, where you multiply like bases, you add the exponents. Well, when you're multiplying inside a logarithm, you add the logarithms together.
Okay.
When you're dividing inside of a logarithm, you do the opposite, which is subtract. And when you raise something to a power of k, in this case a k power, well, a power is just repeated multiplication. So you basically apply rule number 1 over and over and over again. And the easiest way to add something over and over and over again
is to multiply.
It by k. So it's k times log base b of m.
All right, so let's do a little proof, because second semester we're actually going to be doing some proofs in this class, not geometry proofs, but algebraic proofs.
Yep.
And when we do algebraic proofs, usually there's some given information.
Yep.
And then we have to prove something by starting with one side of an equation or an identity later on and getting to the other side. You can't work on both sides.
This is not solving an equation.
It's not.
You're being told something is true. And you're asked to prove it's true by starting on the left and moving to the right, or vice versa.
Correct.
But you don't get to do...
It's stuff to both sides.
Yeah, that's solving an equation. That's totally different.
Okay, so let's start off with the premise, or the assumption, if you will, that x equals log base b of m, and y equals log base b of n.
All right.
If that is true, and we know that this is in logarithmic form, what else do we know is true in exponential form?
We know that b to the x power is equal to m.
We do.
And we know b to the y power is equal to n. And the reason we're doing this will become crystal clear in just a short moment.
Okay, so the what's this called? The property from the previous page that we're going to prove is the first one.
Shall we write it down?
So the first property says log base b of m times n
equals log base b of m plus log base b of n. Okay, so what we're going to try to do is prove this by starting on the left side, doing something fancy to it, and eventually ending up with the right side as our final expression. But we're not going to work on both sides.
We're not.
Start with one or the other.
Okay, we can, however, use all of this information. So when I see the log base b of m times n, I don't really have to use m and n.
Why don't we use b to the x and b to the y? Because that's what we said m and n equal.
So we're going to have the log base b of b to the x times b to the y.
And that's just straight up substitution.
Okay? All right. Now what?
Well, we can simplify the inside of that.
We could, because when we multiply two bases that are the same,
we add the exponents. So we get log base b of b to the x plus y. And in the last lesson, we talked about how to do this very quickly. Those bases basically cancel, and you're left with x plus y.
I'm going to kind of go all over so I don't run out of room here.
That's fine. But we started this whole thing off with an assumption that x was equal to log base b of m.
Okay.
So we will replace x with log base b of m. And y was going to be replaced with log base b of n. And why do we want to replace that? Well, that's the other side of my equation. That's what I wanted to show.
Ta-da!
Now, this is one of those things where why'd you start with x equals that and y equals the other thing? Well, because somebody figured out that that worked really well. And you're not expected to do that right now. But if you had that in front of you, or you had to do one just like it, like they will in class.
On the worksheet?
I don't know. Maybe the same thing. All right. So anyway, that proves that this rule will work all the time.
And it also shows us that we could start on the left and get to the right, or we could start on the right and get to the left. Fine. let us solve.
Got 3 pieces on the first one.
Okay. Ooh, 3 pieces.
I got
So,
e, which is a base,
it is.
to an x minus 2 power.
Yes.
And I'm solving for x, which is an exponent.
So if I wanted to, I could simply put this into log form, which would be base e. Oh, our board's not being happy. 19 equals x minus 2. But log base e.
That's really just a natural log.
It is. And the natural log is really just a button on your calculator. Now, one thing you want to be very, very careful of is don't evaluate natural log of 19 yet. You don't have x by itself yet. You want to get one expression so you can type the whole thing into your calculator and get an answer without any rounding error.
Yes, because the people that are going to type this in now are going to round it off.
They are.
And when they round it off now, and then they do other things, and then they round off their final answer, they're just going to get it wrong. Because they're going to mark it wrong, because it's not right to 3 decimal places.
We are. Okay.
That's
so,
the official right answer.
into your calculator, you will type this because it is a base e, and you can do that. And you're going to get 4.944. Ta-da! How do we check our answers, Mr. Lucky?
We could plug it back into the original problem.
We could, and make sure that it's the same.
All right.
And we strongly recommend when you're solving, you should probably check your answers.
Good idea.
Okay, so letter B is a little bit different here because it's just got more junk.
So let's get rid of the junk, because
Let's get
really
rid of the
what
junk.
we're trying to do is get the exponential part by itself. When you solve equations, you're really undoing operations. So it should make sense to you that we undo the order of operations, and exponents and logarithms fall under the E, and that please excuse my dear Aunt Sally part. So get rid of everything that's multiplied, divided, and added and subtracted in the proper order, just like you would.
And
So
don't be tempted to go 3 minus 5, please.
do not do it. Your best bet on this is to take your time.
Okay,
Next thing you should do is get rid of the negative 5 by dividing it.
watch your signs.
Gives
So we
us-
get 2 to the 3x equals, and again, do not evaluate it on your calculator, just make it 17/5. You can make them positive because a negative divided by a negative.
And 17/5 is really going to come out to a 1 decimal point, so they're probably going to be okay there, but
Yeah.
just don't get in the habit.
Okay.
All right, it's an exponent I'm solving for now.
It is. So I could, if I wanted to, change it to a log base 2, blah, blah, blah. Or, if I'm solving an equation, whatever I do to the left, I got to do.
To the right. Now,
the
we're
right.
just going to show you another way to do this, and your choice in how you do it is up to you. You can simply take a logarithm of both sides. We did this in the last video when I was explaining where one of those rules came from. And we're just going to take a log on basically a log that your calculator can do, preferably.
So either the natural log or log base 10. And since this 3 to the x is the exponent,
It can come out in front as 3x times log of 2.
okay,
It equals log of 17/5.
alrighty,
All right, now,
we're trying to get x by itself.
and right now x is multiplied by a bunch of stuff. It's multiplied
is.
by 3, and it's multiplied by log of 2. So we're just going to divide by 3 log of 2.
Oh, you know what I meant.
Okay.
Now just type all that into your calculator. Be very
Piece of cake.
careful.
Now, the biggest issue people have in their calculator that I see is that they do not divide the entire top by the entire bottom. So to be safe, you actually need parentheses around the denominator more than anything.
Oh, thanks.
If you want to be real safe, you just put the whole numerator in parentheses, the whole denominator in parentheses, and just divide it. So you'll type in log of 17/5 divided by, but make sure you put parentheses around that 3 log 2.
Definitely.
And try it. Take out your calculator right now, pause the video, get it out, try this, and make sure that you get the same answer we got on our paper, which is approximately what number?
0.589.
And if you don't get 589, then figure out a way to type it in so that you do, so you know how to use the calculator correctly.
And if you still can't get it, come and see us. Because we want you to get the right answers. We don't want you to do all the right algebra and pre-calc stuff and then hit a wrong button on the
It's
calculator.
kind of silly, actually.
Absolutely.
All right, next
Okay,
one.
so these two were exponential. What do we notice now?
We're solving for x, but x is inside of a log.
Ta-da!
It's like in a forest in a log. Never
Oh,
mind.
that x right there.
We need to undo the logarithm, and what do we,
We
do
do.
to undo a logarithm?
We change it into exponential form.
So we have 2 to the 4th equals x. We're done.
Hey, that's 16.
That was hard. I hope they're all like that one. The next one looks basically the same, except for you got more junk.
We got
I think that's
more
the word we used
stuff.
before.
It was. We got to get rid of everything that isn't log of x. Okay, so we're going to minus our 7. So we've got this, negative 12. We're going to divide by a negative 3. Now, some students at this point are tempted to make that negative 3 into an exponent, and you could do that, but it makes it really messy
Yeah,
to
we
solve.
want to keep x as simple as possible.
So now we get that log of x equals positive 4.
Now, what's that base on that logarithm
Oh,
again?
it's a 10.
So this is just 10 to the 4th equals x, and that means that you got a 1 with 4 zeros after it. I think they call that 10,000.
Ta-da! Again, you could plug these back in to check them, especially if you know the change of base formula or if you have the fancy TI-84 with the new operating system.
That's a lot.
Okay, now C and D both had one logarithm. If we look at the next ones...
We have 2 logs.
Your turn.
Almost like a forest. Okay.
Didn't you say that last time?
I don't know.
All right, so what we want to do is we want to deal with one log at a time. So if I have 2 logs separated by a plus,
We can put 1 log and multiply the insides.
we could.
So
So
we're
let's
gonna
go log of x,
Log of
x times,
x times
X plus 21. and it still equals 2. Okay, now we still only have 3 pieces. We have a base of 10, and we have an input of x squared plus 21x, and it equals 2 the exponent. So go ahead and change your format into exponential. So 10 squared is x squared plus 21x. I got it. Okay. An x squared and an x.
Notice we're done with logarithms and exponents, and
We're
now we're
done.
back to chapter, like, Algebra 1, Chapter 10.
Yeah, pretty much. When we need to solve with an x squared and an x, we're going to need to
Factor!
which means it has to equal 0.
And if it doesn't factor, then you probably just need to use the quadratic formula. But
You do.
this factors, because we made it that way.
It does. The other thing to remember is that when you factor, it's typically easier to factor with the x squared being positive. That's why Mr. Lucky moved the 100 to the right-hand side. Did you pick 25 and negative 4? You're so
did.
good at factoring. Okay, so then when we solve, we're going to get x equals negative 25 and x equals 4. But a minute ago, we said we should probably do what with our answers?
Check them, because right now I just want to go high five and be
Them.
happy.
Yeah, but we have to check them.
Dang it.
And the most important thing, if you think about the graph of a logarithm
Logarithm graph.
graph always has that vertical asymptote
That's a
along
terrible picture.
the y-axis. So as Mr. Lucky's redrawing this beautiful picture,
Dot, 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 dot.
notice that the domain is got to be from 0 to infinity. Anything more than 0. You can never input a negative into a logarithm.
And if they remember from chapter, I think it was P,
Okay.
when we first talked about domain, maybe it was 1, I don't remember.
It was chapter
We
B.
had 3 domain issues.
We did.
No zeros in the denominator, no negatives inside the square root, and the last one, no zeros or negatives
zero, yeah.
inside of a logarithm.
Correct.
Which means that when you look at this original function, you have an exit here. You cannot have negative numbers or 0 inside of that logarithm function.
Which means that negative 25 is
Is
not allowed
out.
to be an answer. It's extraneous.
Just like it was when we had fractions and we didn't have that in there. And we need to check them. Now check 4. Is 4 going to make any issues?
It's going to be positive, so it should be fine as long
Should
as
be
all our
okay.
arithmetic is fine.
Now you could probably double check it on your calculator to make
Okay.
sure, but what we're trying to say is make sure you check your answers. Is it okay to have a negative x value as an answer? Yes, as long as when you plug it into your logarithm, it doesn't give you a negative number inside the logarithm.
Right, the input of the logarithm can't be negative.
So don't just cross out all the negatives.
Yeah, you have to think. You have to use your brain. If it said something like 3 minus x, then, you know, I got excited. Sorry.
Throwing papers around.
I am.
Let's do the last one.
Do you want to just go to a new page and I'll tell you what it says?
Ours new page.
Oh, perfect.
You
Okay,
still
fine.
didn't tell
So
me
we
what
have
it
2
says.
logarithms. We have a subtraction in the middle. So we're going to change that to the log base 3 of x plus 4. I'm talking. You're not listening.
I'm trying to see the problem. They don't understand.
Divided by x
the
minus
microphone
5.
is hanging in the middle
I
of
could
it.
have fudged it.
It puts a big shadow on the problem. I don't know what I'm writing.
X minus 5. Okay, so now we have one logarithm. Go ahead and
Yay.
change your format. 3 squared is going to equal x plus 4 over x minus 5. Please, 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 please. Do not cancel x.
It's totally wrong.
Not that we've ever seen that before.
Nah.
Okay, maybe once or twice. So 3 squared is 9.
All right.
And we have equals x plus 4 over x minus 5. So we have to get rid of this x minus 5 in the denominator. We're going to multiply both sides or the whole equation by x minus 5. Which
like we
means
did earlier.
on the left-hand side, we're going to have 9 times x minus 5.
Which is 9x minus 45.
It is. And it's going to equal x plus 4.
Woohoo.
Keep solving algebra 1. Move your x's, move your 45s. Beautiful. Divide. And actually, if you want to leave it 49/8, that's a beautiful answer for us. We like fractions.
Double check.
Plug it back in.
Does 49/8 plus 4 make a negative number?
No.
Does 49/8 minus 5? Well, then
Oh, we might have to think.
well, 8 times 5 is 40. So
Okay.
49/8 is bigger than 5.
Oh, so we're good.
We're okay.
Because bigger than 5 minus 5 is still bigger than 0.
What she said. I don't think we got any more.
That's it.